Okay, let's get started. Really excited for this session. We have with Databricks and with Elise from Databricks, we have Hydrating the Lakehouse. And this session is all about simplifying data ingestion across the enterprise into your Databricks Lakehouse environment. And for this session, I'm joined by Elise Joris. She is a senior staff product manager, excuse me, for Databricks. And I'll let you introduce yourself, Elise.
Yeah, nice to meet everyone. Glad to be here. I'm on the product team here at Databricks. I focus on all things data ingestion.
Excellent. Great to have you here for this session, Elise. So just to quickly cover the agenda for what we're going to be talking about on this session, we'll touch on, Elise will present on the Databricks data intelligence platform and some of the traditional challenges with data ingestion as it pertains to a data store like Databricks. And we'll talk about, Elise will present on Databricks and Lakeflow Connect, which is the native ingestion module for Databricks. And then we'll touch on how CData complements Databricks native functionality to extend your connectivity into external data sources from the Lakehouse. And we'll do a session looking forward on the roadmap from Databricks perspective. So really excited for this session. Elise, I'll let you kick it off.
Thanks, Varun. So I'm going to start with why getting data into Databricks is so valuable. I want to spend just a few minutes kind of level setting on the Databricks platform. And the summary is that every company aims to be a data and AI-driven organization. It's no longer just about data. AI is essential to success and continued innovation. Organizations want, personalized customer experiences, fraud detection, dynamic pricing, predictive maintenance, supply chain optimization. The list really goes on because every industry leader is actively integrating data and AI. And these advancements deliver significant improvements to both top-line revenue and operational efficiency. But it can be hard to deploy that at scale, especially with low cost, high quality, and strong governance. After all, the current state of data and AI systems is highly fragmented, which we as ingestion users are all acutely aware of. For example, the one I hear all the time is that organizations have multiple CRMs or ERPs or data warehouses, maybe from acquisitions, or they're just legacy systems. And over time, this becomes a patchwork of data environments that makes it harder to get value from and to govern your data. So to address these challenges, Databricks offers the data intelligence platform. The goal is to unify data and AI into a single cohesive strategy. Specifically, it reduces costs and consolidates data, breaking down silos and freeing up budget for more interesting work. It also enhances governance and security, and it helps you operationalize AI, removing technical barriers so that you can leverage AI effectively. So how does it do that? To start, Databricks offers unified support for Iceberg and Delta Lake so that you can avoid unnecessary data duplication and format or vendor lock-in. Building on that, Unity Catalog provides a comprehensive governance framework. It goes beyond standard access control to also include data and models and code governance, ensuring that your data is consumable, high quality, and easy to manage across your teams. Next, we layer analytics and AI on top of that. Both become a lot more powerful with knowledge of your data. After all, traditional analytics relies on asking questions from a data warehouse and plugging in a BI tool to visualize results. But when data intelligence is applied to data warehousing, you get natural language that understands your context, powered by strong price performance and AI-driven optimizations for better query execution. For example, AI BI dashboards make it super simple to create dashboards with the assistance of AI. But if you need to explore the why behind the dashboard, or if you just have an ad hoc question, AI BI Genie lets you ask questions in natural language, no SQL needed. It actually understands your data, unlike BI tools that are just converting the question into something generic. Similarly, with AI, you wanted to understand your domain and the uniqueness of your business in order to solve specific tasks. And success here isn't necessarily about selecting the best model. That changes every week, and the best option depends on the task. Instead, it's about how quickly you can evaluate models, develop agentic systems, and get them into production. And the unification of Databricks allows you to develop agents that can reason on data from across your data estate. We support every foundation model on the market, and we make it easy to tune them with your data. Plus, you can compare models over time to swap in new models as the market evolves. You're never locked into a cloud or a model provider for anything. And then finally, you have the tools to evaluate and monitor models in production to ensure that they're performing as intended. Now, there's one big hole in that overview I just gave, which is ETL. How do we actually get your data into the Lakehouse to make all of those fancy tools work? Well, fragmentation, I think, is particularly relevant here because data is all over the place. You have it in SaaS applications, you have it in databases, you have file sources, message buses, APIs, and so on. And it can be really difficult to get that data into your Lakehouse. To start, SaaS APIs are hard to ramp up on. Sources often have multiple APIs. Which API is right for you? Which minimizes cost? Which maximizes performance? You might even need multiple APIs, maybe one to query the schema and another to actually ingest the data. And then you also need to consider API limits and pagination, authentication, cursor keys, test instances, and so on. And that's all where you start thinking about source-specific quirks. So for example, Salesforce has columns called formula fields, which don't update the primary key even when they're changed. Or with ServiceNow, you got to be careful about how much you're hitting the API, because if you hit it too much, you can actually harm the performance of the data source. Or if you want raw data from Google Analytics, you're actually not building a Google Analytics connector, you're building a BigQuery connector. So now you need to deal with two systems to get at that data. Or maybe you're ingesting from SharePoint for a RAG application. If that's the case, you're probably going to want to design a solution to ingest file ACLs to ensure that your chatbot doesn't reveal information that the user's not supposed to have access to. And that's just SaaS pipelines. Database pipelines are even harder to configure and manage, especially without impacting the data source. For example, different databases have slightly different SQL dialects, they have different CDC strategies. Which syntax does yours support? Which features can you rely on consistently? Even permissions can vary. A DBA might give you read-only access to some tables, but it might block others or restrict queries that have a really high performance cost. And once you have all that sorted, you might start thinking about the bells and the whistles like SCD2, query pushdown, and none of those is easy. So you have to do a lot of work to build these pipelines, to optimize them, and particularly to maintain them over time. And spending time on all that gets super expensive, which ultimately slows your time to value. It doesn't help that these pipelines often require a really specialized data engineer, and data engineers are super high demand and have a bunch of work piling up. So the people who need to use this data, for example, perhaps a marketing analyst who's using AI BI, they're all blocked. It's really the opposite of democratization. And you might not even want to democratize the data when you have a patchwork of pipelines, because going back to that disjoint governance, who's tracking lineage to make sure we're not duplicating all of the tables, or that everyone's implementing data governance best practices and CI/CD, that nobody's blowing up the company's data engineering bill, and that everyone's respecting data retention and PII policies. So at the end of the day, a lot of organizations aren't fully utilizing their data. They're often running into pipeline outages, and they might even have some security and governance risks. And I don't need to tell this group that this is just step one of many. It gets even more complicated as we layer on transformations and orchestrations and so on. So to address this problem, Databricks offers Lakeflow and bolsters those offerings with the partner ecosystem. So I'm going to first talk about Lakeflow, and then we're going to talk about the partner ecosystem. Lakeflow is a unified data engineering solution for ingestion, transformation, and orchestration. It's essentially our vision for what data engineering should be in the data intelligence platform. And why I think it's so great? Well, to start, Lakeflow provides an end-to-end experience across all these steps. So it really simplifies the ETL stack within Databricks. It's also easy to use for people who want that kind of simple point-and-click experience, while also being quite high-powered for users who are fluent in PySpark and they have needs like sub-second streaming. And then it also produces reliable, fresh, and accurate data that downstream users can trust. For example, Lakeflow is integrated with proactive data quality monitoring and alerting, and so you can monitor data quality over time and make sure that you're keeping things consistent. In terms of the actual products, there are three pillars. Connect is for ingestion, Lakeflow Declarative Pipelines is for transformation, and Lakeflow Jobs is for orchestration. And I'm going to dive specifically into Connect because ingestion is our focus today. To explain this product, I want to talk about the three things that we're kind of excited about. The first is simplicity, the second is unification, and the third is efficiency. The connectors are easy to set up. There's a simple wizard, and you can create a production SaaS pipeline in 4 steps, a production database pipeline in 5. There's also an equally simple API if you prefer to code rather than to click. And once you've set a connector up, it's also fully managed. Insofar as we have the ability to solve a problem, Databricks holds the pager when something goes wrong. So practically, we're providing things like automated schema evolution, robust observability and alerting, automated retries and error handling, automated connector upgrades when third-party APIs change, SCD type 2, change data feeds, and so on. But it's not enough to make ingestion simple in isolation. We also need to cleanly unify it with the rest of the data intelligence platform. For example, this product is integrated with Unity Catalog for governance, Lakeflow Jobs for orchestration, Databricks asset bundles for CI/CD, data classification for PII, and data quality monitoring, and so on. But what might be truly special is how we handle incrementalization. We're quite efficient at reading, writing, and transforming your data, which directly impacts the cost and the performance of your ETL. Now, for starters, we incrementally read the data, only pulling the data that's changed where possible. And there's no blanket approach to this. We're often optimizing for each source and sometimes for each table. But incrementalization doesn't stop at reading your data. We can also generally write the data that's actually changed, so you can use things like change data feeds to capture a history of those changes. And we still don't stop there because, again, ingestion is just step 1. We actually write the data to support incremental processing downstream as it works its way through the medallion architecture. So for example, if you want to construct a materialized view to do downstream transformations, features like Enzyme can process updates to your view incrementally, meaning that it only updates the rows it needs to, based on what changed in the input. Over time, this can significantly improve the performance of your transformations. Our benchmarks on an MV with 200 billion rows show that incrementally refreshing it using Enzyme can provide up to 340 times better price performance over fully refreshing the same view. So here's the set of sources that we support in Lakeflow today. And many of these are those fully managed connectors. We also offer a series of customizable connectors like Autoloader for cloud storage or message bus connectors for Kafka, Kinesis, and so on. But I would venture a guess that most people here today have a long list of data sources that aren't on this list. Ingestion partners like CData significantly expand the scope of connectors that we can offer. So you get maximal data coverage and optionality as you hydrate the Lakehouse. So that means, beyond our native Lakeflow Connect, you get to bring in hundreds of additional data sources through CData, all feeding into open Delta tables for analytics and AI. So with that, I'm going to turn it over to Arun, who's going to speak a bit more on CData.
Yeah, thanks, Elise. And so, as Elise has detailed here, Lakeflow Connect provides a strong native framework for ingestion. And Databricks obviously provides that Lakehouse foundation, but customers often need broader connectivity to SaaS applications, ERP, CRM, legacy on-premise systems that aren't covered out of the box. And so that's where CData Sync comes in. Sync is a universal data ingestion platform with hundreds of connectors for any source, whether it's on-prem, whether it's in the cloud, whether it's private cloud deployed, and it can move all that data into the Databricks Lakehouse. One of the key elements of Sync as an offering is that we have flexible deployment model. And so you can have it running on-premise, you can have it running in the cloud, you can also have it running on your own private cloud infrastructure. And these pipelines will land the data directly in open Parquet and Delta table, open table formats. So Sync gives customers the breadth and control that they need to bring all their data into Databricks, and it's governed and ready for analytics AI. We are a trusted Databricks ecosystem partner. And really, I just want to go into how CData and CData Sync in particular make an ideal partner for Databricks customers. So like I mentioned, Databricks provides that Lakehouse foundation. What CData brings is that flexibility of deployment and connectivity. So As I mentioned before, you can run Sync on-premise, you can run it in your own cloud, you can run it in the SaaS model, and it connects everything from modern cloud applications to legacy systems like your IBM Informix and DB2. So that way, even the hardest to reach systems that are part of your infrastructure can become a part of the Lakehouse, where they're ready for governance, the Unity catalog, and the AI analytics functionality that Elise just went over. With Sync, you also have complete control over how your data is replicated and ingested into Databricks. So nothing changes from source and the data extraction through landing it into Databricks without your input. This means no forced normalization of your data. Many ingestion partners will require normalization of your data, but in this case, you have complete control over the way that that data is represented in Databricks based on your needs. So it delivers a raw replica, so accuracy and lineage are very clear. Sync also has schema level mapping and granular transformation, so you can map and transform at the schema or column level, and that gives you precise control over exactly how that data lands into your Lakehouse. And we also support append-only or Parquet override modes for the open table formats without vendor lock-in. Sync is also built for high volume performance. We have connectors that can handle CDC across 9 on-premise database systems, both relational and NoSQL. We support incremental replication, as Elise went over with Lakeflow Connect. That is something that Sync also supports from over 150 sources. We support parallel processing and clustering modes for scalability. So you can scale both horizontally as well as vertically within the platform. And we can support some pretty high volume, high frequency data loading use cases. Some examples of the types of thresholds that we can easily surpass are listed here. We can cover over tables with over 100 million rows, 700 plus columns, and over 10 billion monthly record changes. Sync also supports reverse ETL. So as much as the data needs to flow into Databricks, oftentimes the analytics that happens and the data blending that happens within Databricks needs to flow back into your business systems in order to enrich the data that you have there. So with reverse ETL and CData Sync, we can push that enriched data from the Lakehouse directly into your core business systems, your CRMs, your ERP. That includes systems like Salesforce, Intact, HubSpot, and more. So that means that teams can act on insights in the tools that they already use every day without the overhead of custom code or point-to-point integrations. Reverse ETL is available directly within the same platform that supports ETL for you with Sync. Sync also does not have volume-based pricing, so it's all connection-based pricing, and that just improves the scalability from a cost perspective. You can, as your needs grow, you can move bigger and bigger tables without that necessarily having an impact on your licensing. So that lack of volume or consumption-based pricing is a huge differentiator for Sync compared to other offerings that are in the market. So I want to touch on some customer stories, some mutual wins for Databricks and for CData. The first example is NJM Insurance. NJM Insurance needed to give its marketing team timely insight into dozens of advertising platforms for marketing analysis, but every new API connection was taking them 4 to 6 weeks of custom coding to develop. But with Sync, they cut that time down to less than 2 days. And so that's a 10x fast improvement in terms of time to value with Databricks for this use case. And it reduced costs by 3-fold, giving marketing analysts a consistent, trusted data source for analyzing campaign performance and customer lifetime value. I also want to share another example with Nintex. Nintex is a software company where analysts were spending over 15 days producing sales and product reports from data sources like Salesforce, NetSuite, and more. So with CData Sync feeding Databricks, that same reporting now takes just 6 minutes. So that's a 99% improvement. And the result is real-time insight into product adoption, renewals, and regional performance with 10x more dimensions available for reporting and a 30% reduction in data management costs. So these are just a couple of examples of how enterprises are pairing Databricks with CData to accelerate real business outcomes. So with that, I'll hand it back to Elise to go deeper into some of those customer use cases.
Thank you. Yeah, more broadly, I think we're seeing a really large swath of use cases across the data intelligence platform. So a very common one, yeah, the marketer needs to get data out of Meta or Google Ads to do their multi-touch attribution, or the HR analyst needs to get data out of Workday to do their comp analytics. Customer service teams are getting data out of platforms like ServiceNow to understand how effective their customer support funnel is. The sales analytics team needs to get data out of Salesforce to do lead qualification. The finance team needs to get the data out of NetSuite Analytics. AI wants to build a RAG on top of SharePoint or Google Drive. The list really goes on and on. And as we continue to see more of those use cases, we're going to continue to build out more functionality. We'll continue to build more connectors. We'll continue to deepen their functionality and so on. But as part of that roadmap, there are 3 particularly interesting trends that I wanted to leave y'all with. So first, we're seeing real momentum in ETL democratization. Citizen developers are getting more involved than ever, but data governance and engineering teams want to ensure that there are standard ways to handle governance, lineage, ingestion, monitoring. So fully managed connectors and modern development practices like CI/CD or Databricks asset bundles are critical. We're also working on better ways to tag your data for PII and to automatically detect potential PII as that data continues to stream in. Now, one area that I think is particularly urgent for democratization is AI. AI engineers want to ingest unstructured data, they want apples, they want metadata, and they want it to be really simple. So you're going to see significant development in this space. We're building more sources like Google Drive. We recently launched previews for Jira and Confluence, and you're also going to see more features like integrations with agent bricks downstream to enable document parsing, vector search integrations, and so on. And then finally, there's Zero Bus. This is where I think we can really help with simplification. The idea behind Zero Bus is, what if you don't need a staging layer at all? What if you can stream data directly into your Lakehouse from your IoT apps, your click streams, and so on? Today, a lot of organizations use message buses like Kafka as transport layers to the Lakehouse. And to be sure, Kafka offers a really durable, low latency way for data producers to send data, and it's a really popular choice when you're writing to multiple syncs. But when you have a single sync, it also adds extra complexity and cost, as well as the burden of managing another data copy. So it's not an efficient choice when your sole destination is the Lakehouse. Zero Bus provides a simple solution for these cases by allowing you to write that data directly. So ultimately, I think with the right connectors, the right governance, the right architecture, everyone's going to be able to participate in unlocking the value of data. And we can really help to simplify things along the way so that every team in every organization really succeeds with data and AI. And with that, I think I'm passing it off to Arun to wrap us up.
Thank you, Elise. And we have one quick question from the audience here, which I'll cover. The question is whether CData Sync can be deployed on your own Azure tenant. And the answer is yes, CData Sync can be deployed on your own infrastructure, whether it's on Azure or on-premise. And so it's not part of CData's Azure infrastructure. So just wanted to address that question real quick. And so with that, that's all the time that we have for today. I want to thank you again, Elise, for joining on and covering what Databricks does and with Lakeflow Connect in particular. And we'll see you all in the next session. Thanks so much.